Alright, in this problem it says, use the given zero to find the remaining zeros of the function. Alright, and so they gave me a function, f of x is x to the third minus 10x squared plus 33x minus 34. And they said it has a 0 of 4 minus I. So to find the remaining zeros, to start with, I know that 4 plus I has to be a root because complex conjugate theorem says that if 4 minus I is a root, 4 plus I is a root. Officially it says if a plus bi is a root, then a minus bi is also a root. So in our case, if 4 minus I is root, 4 plus I is root. So to start with, I know that it can't be these two because they put negative 4 minus I. So it has to be the change in the imaginary term. So 4 plus I. So I just need to check to see if negative 2 is a root or 2 is a root. This is the joy of multiple choice. So I'll check negative 2 first since it came first. So I put 1 for x cubed, negative 10 for x squared, 33 for the x term, and negative 34 for the constant. I have 4 terms, 1, 2, 3, 4, and it's a third degree, so that's good. Bring down the 1, negative 2 times 1 is negative 2, add my column. Negative 2 times negative 12 is positive 24, add my column, and I get 57. Negative 2 times 57, I can tell that if I add that together, it's not going to be 0. Okay? It comes out to be negative 114, but I can tell when I add those, I'm not going to get 0. So I hope positive 2 works. So I put 1, negative 10, 33, and negative 34, because that didn't work at all. So I bring down the 1. 2 times 1 is 2. Add my column, and I get negative 8. 2 times negative 8 is negative 16, and I add my column, and I get 17. 2 times 17 is 34. Woohoo! That works. So there's my correct answer. So on a problem like this, it wouldn't be, if you had to use complex conjugate theorem or a rational root theorem to figure out the zeros, it would be harder, but it's multiple choice. So you just kind of have to know something about complex conjugate theorem and then just try out these other zeros, see if they work.